Welcome to UBG Bytes.
Hello.
Today we're going to look sort of under the hood of macOS. Specifically, we're talking about some foundational bits called Mach primitives.
Right. Our goal here isn't to get super technical or, lost in the weeds. It's more about highlighting some key ideas that really explain how macOS works at a fundamental level.
Exactly. We want to give you a clearer picture of what's going on inside based on, well, how operating systems generally function.
I think of it less like a lecture, more like pointing out the really interesting essential stuff that makes your Mac, well, tick.
Okay, so where should we start? How about with ports?
Good starting point, yeah. So in Mach, a port isn't like a physical USB port.
No, definitely not. It's more abstract.
Right. It acts like a secure communication channel. Imagine maybe a very specific mailbox.
A mailbox, okay. And only certain things can access it.
Exactly. Only specific tasks, which we'll get to, have the rights to send or receive from that particular mailbox, that port.
And this is key for inter-process communication, right? IPC. That's how different parts of the system or even different apps you're running talk to each other.
That's it. Ports are absolutely central to how Mach handles communication. It's built around them.
And what's really cool, I think, is that controlled access. It's not just wide open.
Mm-hmm. The system is very careful about handing out those permissions, those rights.
So one app can't just randomly mess with another app's communication channel.
Precisely. That control is fundamental for stability, for security. It keeps everything sandboxed, in a way, at the communication level. It's a capability-based system.
Okay, that makes sense. Like a verified postal service, maybe? Only approved senders and receivers.
That's a pretty good analogy, actually. It enforces boundaries right at the core.
So if the ports are the secure mailboxes, then the messages must be the letters, right?
Exactly. That's the next piece. Communication happens by sending these messages between ports.
And these messages, they carry the actual information, like requests or data.
Yes. They're the vehicles for interaction. It could be a simple signal, a command, or even quite complex data packed into the message. It's a structured format.
Can you give us an example, like something you might do on your Mac every day?
Sure. Okay, let's say you hit save in your text editor.
Right.
Your text editor application, running as a task, would package up the file data, maybe the file name, into a message. And then it sends that message to a specific port that the file system service is listening on. The file system task receives the message, unpacks it, and performs the save operation.
Huh. So even just saving a file involves this underlying message passing.
Absolutely. It's happening constantly behind the scenes. And the system is flexible. These messages can handle really simple things or quite complex interactions. Very elegant, really.
Okay, so we have ports as channels, messages as the content. You mentioned tasks using them.
Yeah.
What exactly is a task?
Right. A task is essentially the execution environment for a program.
So when I double-click an application icon,
the operating system creates a new task for it. Yeah. That task gets its own chunk of memory, its own resources.
its own sandbox, basically.
Sort of, yeah. And, crucially, its own set of ports that it can use to communicate.
So every running app is its own task. Mostly.
That's the general idea. It provides that boundary, that isolation we talked about, process management 101, really. But Mach has its specific take with tasks.
And I guess even a simple-looking app might actually be more than one task working together.
Oh, definitely. Many applications use helper processes or background services. Each of those might run as its own task.
And they'd all be communicating using these ports and messages we've been discussing.
Exactly. It allows for modularity. If one helper task crashes, it doesn't necessarily bring down the main application because they're separate tasks communicating in a controlled way.
Enhances stability. Got it. Okay, one more piece then. Threads. Where do they fit in?
Okay, so within a single task, you can have multiple threads. Think of threads as the individual workers inside the task. The task is the environment. The threads are the ones actually doing the work, the executing streams of instructions.
And a task can have more than one thread running, seemingly at the same time.
Yes, concurrently. That's the key. It allows a single program, a single task, to do multiple things simultaneously.
Like my web browser example, one thread drawing the page, another downloading an image.
Perfect example. Another thread might be running some JavaScript. They all operate within the same task, sharing its resources like memory, but executing independently.
And Mach manages scheduling these threads, deciding which one gets to run on the CPU at any given moment.
Exactly. Thread scheduling is a core kernel function. Mach handles divvying up the CPU time amongst all the active threads across all tasks.
So this is how apps feel responsive, right? If one thread gets stuck waiting for, say, the network.
Other threads in the same task can keep running. The user interface thread can still respond to your clicks, for example, so the app doesn't just freeze.
Makes the whole system feel smoother and use the hardware more efficiently.
Precisely. Better performance, better responsiveness. It's all about concurrency within that task boundary.
Okay, let's try and connect the dots then. We have tasks.
The program's environment.
Right, and they use ports
The secure
to
mailboxes.
send and receive messages.
The letters containing data or requests.
And those messages often trigger actions that are actually performed by threads.
The individual workers within the task. You got it. That's the loop.
So ports, messages, tasks, threads, they're all working together.
It's this interconnected system, this modular approach built on these primitives is really core to the macOS design, inherited from Mach. It allows everything to interact in a controlled, efficient, and pretty robust way.
Well, hopefully walking through that gives you listening a better sense of what's happening deep inside macOS. Understanding these concepts, ports, messages, tasks, threads, it really does give you a different appreciation for the complexity, but also the elegance under that user interface.
Absolutely. These aren't just abstract concepts. They are fundamental to everything your Mac does. Running apps, system stability, security, it all relies on this foundation.
Yeah, it's quite something when you think about it. So reflecting on this whole system, what part kind of stands out the most to you?
For me, it might be the way the secure communication via ports enables that robust modularity. It's quite clever.
Interesting. Yeah, there's definitely more to explore in the world of operating systems. But maybe, think about how these ideas, controlled communication, breaking work down into concurrent parts, might apply elsewhere, maybe in other complex systems you see around you. Something to ponder.